Let's talk for just a few minutes about how we describe scatterplots. Describing scatterplots is different than when we described distributions in Unit 1. Describing scatterplots, we want to focus on three main parts: the strength, direction, and form. So for strength, we talk about strong, moderate, or weak. And we use the R value to support our claim. If R is between 0.7 and 1, we consider it to be strong, and that's the absolute value of R. Because even if it is negative, it can still be a strong correlation. And then if R is between 0 and 0.3, it's considered no correlation. And then other values, such as between 0.3 and 0.7, you can make an estimate as to whether or not you feel like that would be moderate or not. For direction, it's simply positive versus negative. So those are pretty self-explanatory, but make sure you don't leave it out because it is something small but very important. And form, we normally look at linear, or is it curved or nonlinear? So here are some options. This one is obviously linear. These two are considered curved, and this one fans out and is still considered curved. So if it is none of these three, but just not linear, you can just say that it's nonlinear. But if it's linear, make sure you don't forget to state that it's linear. These three words are usually pretty simple, but sometimes we tend to leave one out. So always remember, when describing scatterplots, you want to describe the strength, direction, and form. Another important part of scatterplots is to think of our R value compared to our R squared value. What's the difference between the two? So our R value is our correlation coefficient. It goes with giving the strength of a correlation. We look at the R value. It helps you to justify when you say that something is strong or weak. You could state the R value if you know it or you can find it. If you don't know it or can't find a specific value, sometimes you can look at the scatterplot and estimate the R value. Using an estimated R value or a given R value or one you can find R squared simply by squaring the R value. This is the coefficient of determination. This is how much of our y is explained by our x, and you'd of course want to use context when describing that. If your correlation is nonlinear, we would need to look at the R squared value to decide which transformation would be appropriate: exponential, log, or power, which we'll talk about more on the next little video. It explains how confident you are when you're making predictions with your least squares regression line. And just keep in mind, these are not the same. They are not interchangeable. So R goes with strength of our correlation, and R squared goes with a couple different things. Again, the main idea is how much of our y is explained by our x. And R squared helps us to figure out what transformation is needed. But when we're only describing a scatterplot, the R is all we need to talk about. Hope this helps to distinguish R from R squared. And one more look back over here. When you're describing a scatterplot, make sure you include strength, direction, and form unless you are specifically asked for only one or two of these. But if you're just asked to describe the scatterplot, make sure you include all three parts.